Alright, welcome back. So last time we spoke about constructing objects, and today we'll be speaking about another way to create objects other than constructors. So let's go back to this point example we had before, right? So we have a point p equals new point. So again, we created a point instance, right, a point object with the constructor. So we had a constructor 2 parameters. So now, instead of having a constructor 2 parameters, let's actually get rid of this constructor. So now if we get rid of this constructor, there's going to be an error here, right? It's going to say cannot be applied, because now the default constructor is going to be the only constructor this class has. As you remember, the default constructor is a constructor that comes with every class and it has no arguments. So for example, if I do this, now it works, right? But there's no values, right? So there's really, the default constructor is not something that we want to use most of the time. So let's go ahead and look at a different way of constructing objects, and let's think about it. So we have this x, we have this y, right? So we can use something called a setter. It's called a setter, right? To set the object. So the setter is going to set the object, and then, or actually in this case, attribute, which might be an object, right? Because you can have objects inside objects. Right? This point class can have attributes or objects, like a string, for example, right? It can have a string, point name, so you can set this object / attribute, right? This is not an object, this is a primitive type, but my point stands that you can have objects inside objects. So objects can be composed of other objects. That's actually very common, right? Alright, so anyway, so setter sets the attribute, okay? And then you also have a getter, which gets the attribute's value. Actually, let's just do this. So a setter sets the attribute's value, and a getter gets the attribute's value. So now you have a setter and a getter, right? And so let's actually construct this setter and getter. So let's just do it for x first. Okay, let's just do x. So you can actually do a shortcut here, right? You can do your command N or your control N and just do setter. And let's just do x. So if you can see, it is void because you're not actually returning anything, right? You're just trying to set the value of this. So basically, this looks exactly like a constructor. So if we do a constructor, right, with just one value, which is x, right, it looks very similar. The only difference is there's a return value here, and here there's not, right? So in other words, we're not actually returning anything in this point. In the constructor, we're returning a point instance, right? And here we are actually just going to update this value. And sorry about that. And here we're actually going to update this value and also return a point object with this value, right? Whatever we pass in as an argument for this parameter. So let's go ahead and just write out ourselves. So first thing first, we're going to do set x. Oops, it doesn't automatically. Doesn't want me to set it myself. Usually you want to set yourself. So first it has to be void, right? So void set x. Say this dot x equals x, right? Well, oh, got the parameter here. Okay. So we say this dot x equals x. So whatever we pass in as our argument for this parameter x is going to be set to whatever x is, just like the constructor, right? Now we make it void. So now if we do point p equals new point, we say p dot set x, right? Oh, pass in 10, for example. If we go ahead and debug this and see what the value is, so it should be 0 and then change to 10, because again the default value for integer is 0. So let's go ahead and step through this. So p currently has 0 and 0, and then we set x. So now we update the value of x inside point to 10, right? Straightforward. So a setter is used to set an attribute's value, and a getter is used to get the attribute's value, right? We're going to worry about setters for now. So as you notice, the default one, right, let's just compare them both. The default one has a access modifier, right? It has public as the access modifier, so that means that anyone can modify this, right? If we make it just without any word before void, now it's package protected, which means that anything in this package, right, can access this function. So why would you use setters and getters when you can just do this, right? You can just do p.x equals 10, and then let's just debug this. Hit debug again, and you notice I just did p.x equals 10 because this is actually also package protected, which means that any other class in this package, which is default package, there's no package, can access this variable. So it means basically anyone. So if I create a package here, let's create a package. We'll call it package1, right? And let's create another package. Oh, these are terrible names for packages. This is an example. Here's package2, right? And let's put point and let's put test both in the same package. And now, as you can see, there's still no errors because they're in the same package, right? So let's go ahead and restart this debugging console session. And looks like my debug point is only up here. I have to move it. Sorry about that. Let me go ahead and hit debug one more time. I think I'm going to move the class and move the debug point. It's kind of weird. So let's go ahead and see what 10 is now x. So again, it does the same thing as p.setx. So why would you want to ensure that people can only modify the value using a setter? Well, it's something called data hiding or encapsulation. It's let's see if I can spell this. Yep. So it's part of the object-oriented principles of object-oriented programming. And what this means is that you want your attributes, in this case x and y, to be only accessible using methods, right? So that no one could just modify these at will. So for example, if these are actually public, whoops, I can't spell today, or any day. If we make both these public, then any other class and any other package can access. So basically public allows anyone to access this. So it's public. It's exactly what the word means. While if you make it private, right? Now even in the same package you can't modify x. And this ensures that you have to use setx or setter to modify the value of an attribute, example, for x. So let's go ahead and stop the debugging session and re-add our p.setx. So now we are ensuring that we're using encapsulation, as in we are only modifying the value of this variable using methods. Now there's one exception to this, but let's just go through this first. So again, we set our x, and just like before, we set our x, we get x equals 10. So let's just hit kill this. Okay, so there's one exception to this, and it's a constant. So for example, public, if you have like pi, for example, right? Pi, actually it's double, sorry. Pi equals 3.1459, whatever else is after, I don't know the full pi, or the first 10. I just know the first 4 decimal points after. So it's 3.1459, blah, 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 blah. But the point is, constant can be public so that if you want to, like, pi is never going to change, right? It's always going to be 3.1459, et cetera, et cetera. So constants are variables that are hard-coded that usually never change, so that you can reuse them across multiple classes. So you can have a constant class. So a common pattern in Java is you have like a constant class. For example, let's just call it constant, right? And let's call it actually math constants, right? So you would have, for example, pi as one of your constants, okay? And then you can just use pi here. So for example, if you're doing like a mathematical formula, you do like something like pi. So to get pi, you just do math constants.pi times, I don't know, the radius. So let's say the radius is like 10 equals, I don't know, it's gonna call it int formula, whatever, circumference, whatever you want to call it. I don't even, oh. Yeah, so you're multiplying a double times integer, so you have to have double on the left hand side. But my point is, there are exceptions to the rule that variables should be private, is that if you have a constant, it can be public and it can be static, so anyone can access it. So in this example, we're using pi as our constant, okay? So if we have any formulas you have to do, and we have like a bunch of classes that use pi, we can just use the same variable from this math constants class over and over again, right? We don't have to rewrite it. So that's an example. So let's go ahead and delete this. So we're not going to do any math stuff here because it's kind of boring. Let's go back to this. Although this is kind of a math thing. A point is, I guess, part of a graph in math. But we have a setter. Okay, so now we learned that we made this and this both encapsulated, right? So we're using encapsulation for these attributes. And then we're going to also do our we can make this public now. So we don't mind making these functions public because we let people set these variables, right? We want functions, or we want classes outside of this package, right? So for example, let's put test in package 2, okay? And let's make this package protected again, so only same package classes can access it. So now test can't access anymore because it's in a different package, right? So this cannot be accessed from outside package, which is not what we want. Again, like I'm saying, we want this to be public so that anyone, any class can modify X using the setter, right? So we don't want people to access it, right, by making this public and someone doing, p.x equals 10. We want people to access it using setters, which is better than letting people access the variable straight up, because then you have security issues, and anyone can modify your classes. Because a lot of times, sometimes you don't even want people to modify your attributes. So you always have to make this private. So sometimes you allow them to modify. In this example, you want to modify x and y, so we let them modify x and y using set x, and let's add set y. So now we have set x and set y, so we have our setters. Now let's do our getters. So our getters actually be very similar. The only difference is, instead of returning void, we have to return a value because we want to get that value, so we return that value. So for example, x is of type int, so we just want to return int. So we see int as our return value, we say get x, and then we just return x. That's it. So our getter is very simple. All you're doing is returning the value. You're not passing anything in, right? Because you already have the value set before. So if for example, if you try to do p.get x before set x, you're going to get 0 because the default value is 0 and it's not set. So you want to do getters usually after you set your values, not before, because it doesn't make any sense. For example, if you have a string here, oops, I just got rid of it. You have a string here, right, like color. Okay, it's going to be null. Let's go ahead and add setters and getters. So we can actually do getter and setter and add both. Okay, so for example, if we'd say p.getColor and then p.setColor, and let's make it blue. Okay, and let's just worry about the color for now. Show this example why you should always do setters for getters. because it doesn't make sense to do getters before setters. That's why. But we'll show you this example real quick. Well, actually, yeah, see, color equals null. So if you do p.get color, let's just actually print this out, because you're not actually doing anything with the value. It's ignored, as the warning is saying. So there's a warning that was saying that the value of p.get color is ignored because you're not doing anything with it. You're just getting it. You're not actually printing it out or setting it to something else or using it somewhere else. You're just getting it. So let's go ahead and run this again. So actually, let's do it twice. Let's do it twice. Sure. To rerun this one more time. Man, this thing is slow. Like I said, the paid version of IntelliJ is a lot faster. Alright. So anyways, so we create our point, we get the color, and we go to console here and we get null. Because default value for an object is null, right? So we're setting this object color, setting this attribute color, and sorry, we're getting this value color, and it's already the default value of null, so there's no value set to override the null value. But there is right here on line 10. So we're overriding a null value of color, saying now instead of null, it's going to equal blue. So now we set color to blue, and we print it out again, and this time we get blue, because we're getting the value after resetting it. Okay, that's very important. So let's go ahead and go back here, and we actually forgot to get y, right? So let's go ahead and get y. Oop. No fields without getter are found. Oh, we have a get y, that's why. I thought we didn't. Okay, interesting. Let's go ahead and move this up here then. Okay. And let's move this up here. So we have our setters and getters in order. So we have all our setters, set x, set y, set color, and our getters. We have get y. I mean, it doesn't really matter the order, because either way, they're all going to be called. So you have get y, get x, get color. Excuse me. So you have your getters, but let's see. This is all good, but what if we want like a red point, right? And then we want that point to be red automatically, like without even setting the color. Like what if we have like a red point, a blue point, a green point, purple point, and so forth, right? We just have to create an object. So we can do this. We can just do p.set color, I don't know, purple or blue, right? And we say point, another point, or point 2, call it p2 equals new point. Now we do p.set color, and we say red, right? And we keep going. We just, I mean, this is fine, right? This is not a big deal. So like, there's no like negative downside of doing this, right? You just, oops, you just, have 3 different points, 3 different colors, okay? The issue with this is the only issue with this really is if you have a point, right, and you change the color, okay? So first it's red, okay, and then later on, after you set point 3, you accidentally set. Well, actually, this is actually a good example. Let's actually run this. And actually, I did a mistake here, which is what I wanted to do. So we have point P equals new point P2 equals new point, and so forth, right? So we set our color to blue, and we say point P2 equals new point, and we do p.set color again, and look what happens. P2 is still null because the variable name that is calling set is still P, not P2. So if we change it to P2, then P2 will turn red. but if you notice though, is that the color got overridden, right? So if you want a blue point and we don't want that blue point to change to red, right? We want a point to always be blue, a point to always be red, and a point 3 to always be green. Then we can use something called inheritance to force that. So we can basically force these colors to be blue, red, and green at all times. Because if you make a mistake and you override the value of color by using set again, because you can use set as many times as you want, right? You can do something like this, right? Just change up all these colors. You can change this to like orange and yellow, blah 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 blah. So I don't want to do it for all these, but my point is, like, you can override the attributes values using setters, right? So setters are something called, well, they create something called mutable objects. So mutable objects are objects whose attributes can change, right? So like, we can override. Right, we can override these values. So we can say, okay, we want a blue point, and then we want a red point, and then we want to, we want to make it green, and then we want to make it yellow. So we're actually not modifying P2 or P3. We're modifying P still. So we actually want to change that so that each point, right, is actually setting the color for that point object, not like P, not the same point as before. But it's still a problem with this, right? Because you can make a mistake, right? Like I did before, right? You can say, like, oh, p.set color green, and you meant to do P3, and all of a sudden, you screwed up. But either way, like, there's something called a thread in Java, and I don't want to get too much into threads right now, but mutable objects, right, have downsides, and these are the downsides, right? They are not thread safe, okay, number one. So let me make a multi-line comment here. So they are not thread safe, which is bad. So we'll talk about multi-threading later in a future section, but remember this from that mutable objects are not thread safe. They can easily be changed over time, which makes them inconsistent / have inconsistent state. So for example, if point was immutable, which is spelled like this, right? The immutable objects, okay, they have, immutable objects are thread safe, so they are thread safe, which is good. Their attributes do not change once they are set, and we can't use setters for immutable objects. So in this example, we use setters and getters, which is fine, but if you're working in multi-threaded applications, you want to make your objects immutable as possible. Now, there are cases where some attributes have to be changed a lot, so you want to have some setters for those attributes. But wherever you don't anticipate changes to your attributes, you can make those non-changeable, as in like only modifiable once. And there are different patterns you can use to make objects immutable, but we'll work on that in the next lecture or two. But for now, just understand that these are immutable objects, that if you use setters and getters to set and retrieve attributes, you're actually making them immutable. And the only pro of mutable objects are they are less memory intensive because you're just modifying address space. So when you create point p equals new point, right, you're pointing to memory address 1, okay? And when you do p.set color, right, you're just, you have your address for your string inside your point, and you're just adding BLU and then like /n to signify the end of the string. So this is how actually it's stored. This is how a string is stored in memory, right? So basically your attribute color is referencing to this value blue in memory, and then when you do, for example, p dot set color to yellow, right? You're overriding this value. So now instead of blue, right, now you have yellow. Okay, so this is gone. So basically this gets swapped out, right? It just disappears. And now instead of blue, it's yellow. Okay, so in other words, you're not using much more memory, right? You're just adding a couple more bytes because now yellow takes up more space than blue, but you're not using much more memory than you were before. Rather than if you create a mutable object like a string, for example, a string is immutable. Okay, so this is actually a bad example. So when you update a string, it's going to create a new memory address for that, but point is going to update its value of color inside the same memory address. So in other words, point's memory address won't change that much, but color, which is a string, its value will actually be written to new memory address because immutable objects. So immutable means it can't change, right? It means that you can't update the memory address. It's not updatable. So you have to update. You have to insert the value that you're referencing to a new memory address. So you have to add more space in memory. But in other words, like if you do string s equals ABC, then you do s equals DEF, right? This points to ABC, right? This memory address. So this is memory address 1. Memory address 1, and we call memory address because you think of it like a home address, right? Like it's where it lives. Its memory lives in like 1. It doesn't actually live in 1, but I'm just giving an example, right? It lives in some memory address, and then memory address 2 is where DEF is located. So now you have double the memory, right? You're using double the memory space because you have 2 memory addresses now, versus if you're using a mutable object, right? Mutable as in MUTABLE, not immutable. If you're using a mutable object, you would be sharing the memory space. You'd be overriding it instead of creating a brand new memory address to store it. So, in other words, mutable objects are less memory intensive than immutable objects. Okay, this is actually a pretty advanced topic. I want to talk about it now though because it's a very important topic. It's something that a lot of classes don't teach at all, and I think that it's one of the most important values of not just Java programming or programming in general. A lot of the new, so Java is a JVM language, which means it runs on a Java virtual machine, and a lot of the newer languages that run in a Java virtual machine, like Kotlin, they have immutability built in because they're not a fan of mutable objects because the fact they're not thread safe. And so immutable objects are the way to go usually. In other words, you want to make your objects immutable as possible. In other words, if you can make your whole object immutable, that's great. If you can't, make it so that all the attributes that shouldn't change are not changeable, and all the attributes that have to be changed a lot, you can make those mutable, but that's fine. You can, as long as you make it mostly mutable. If you have to make some parts mutable, then that's okay, but you shouldn't like always use setters and getters. Like for example, this is actually bad coding practice to use setters and getters. It's actually a very common trait. A lot of programmers do this when they're lazy or when they don't have to worry about multi-threading. So if you're not worried about multi-threading at all, go ahead. But then later down the line, if you have to make your application multi-threaded, then you have to redo all your objects. You have to recreate them all, and that's going to take a long time. So it doesn't really hurt to make them immutable other than the extra memory space. So you have to be conscious of memory space if you're working in a low memory environment, which is not common these days. Most Java applications run on a server that has a lot of memory. Okay. So anyways, back to this example. Let's actually stop here because we talked about a lot, and let's talk about inheritance in the next section.